Okay, we are doing second problems, and we introduce two new challenges in there. First, this pipe is submitted to two different torques at different places. And also, it's a pipe and not anymore a road, a solid road. So what will change is first, the equation for the polar moment will be that one, pi divided by 2 time the R2 at the fourth minus the R1 at the fourth. We need to remove the polar moment of the inside. And second, we have 2t. So what we need to do, because we want to find the shear stress at A, we need to do a tiny little free body diagram. So we are at A. We have T2, that will be 400, and the T1, the minus 600. So here we will have in that directions a plus 200 pound. Okay, so we add them the same way we add the forces. We do sum of the moment equals 0 minus 600 plus 400. We get the plus 200 equals 0 to get our moment. Sorry, I did that fast. Let me know if you have question on that. Again, we need to look at the unit. So we will use at the end, we want some uh, pound per square inch or kilopound per square inch, PSI or KSI. So we will make sure that we use pound. So T, that will be in pound per a pound time inch. Okay, even if it's given in feet, we need to get that in inch. Rho, that will be in inch, and J, that will be in inch at the fourth. Okay, so we need to check those units. So let's find J first. J equal pi divided by 2, and the outside radius R2 is given, and this is this one, 1.25, and R1 is 1. So we have 1.25 at the fourth minus 1 at the fourth. Be careful, always double check what is given. Is it the diameter or is it the radius? If you have the diameter, you need to divide by 2. I see a lot of mistake on that. Okay, it's a base, and I remember even me making a huge mistake on that on one of my exam, like midterm, and everything was coming from that, and I got a very bad grade. Little parenthesis. So this is for J, and we get for J 2.26, and keep your other numbers after that, 2.64, blah, 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 64 inches at the fourth, okay? Me, I store all my data. In fact, I program everything, so it's always the exact number that I use. Make sure to use the exact number. And now the shearing is equal to tau. Okay, so tau is 200, but 200 is pound times feet. I need to multiply by 12 to write them in pound per inches, and time inches. And after that, time the rho. So the rho, this is distance. So A, it's right in the middle in between the two, the inside and the outside diameter of this pipe. So time 1.125 and divided by the J 2.264. So it gives us tau equal 1.32, 1.32. Let me add a little bit more numbers after that. 1,325, and this is PSI because we have pound and inches, and we can rewrite that tau equal 1.325 KSI, so kilopounds per square inches. So again, be careful with your units. Make sure you have everything in pound and inches, no feet anymore. Make sure that you use the radius for the polar moment and for the distance, rho. And after that, you will be all good. And make sure to make a little free body diagram for your torque if there is multiple torsion on your pipe. Hope that makes sense. Bye-bye.